This is a very quick overview of the secondary computing PGCE at the University of Roehampton. I'm Miles Berry, I'm Professor of Computing Education at Roehampton and lead the secondary computing course. Before I started at Roehampton, I spent 18 years working across 4 different schools, much of that time as an ICT coordinator. Roehampton have allowed me to go and do other interesting things alongside the PGCE work that I do, so I was part of the panel who drafted England's national curriculum for computing and have been involved in a lot of the implementation projects since then. This process of teacher formation is a hugely important one. The quality of any education system rests on the quality of its teachers. And so finding the right people to become teachers, equipping them with the craft skills and background understanding that they need in order to be effective teachers is really very, very important. This is as true of computing as any other subject, but in computing we face a real challenge of persuading people, of recruiting people into the teaching profession. When they get to that point, it is such a rewarding thing for them to do and making a huge difference to young people's lives, giving them love of this subject, giving them the understanding of these principles of computer science is such a rewarding and exciting thing to do. We do continue to face a recruitment challenge into secondary teacher training for computing. For pretty much every year of the last 10 or so, we have not met the government's own targets for the number of teachers required in order to maintain the supply into the profession. And the current year's figures look even worse than they have been over the years up to this point. The model we have of teacher training is very much an apprenticeship one, of new teachers working alongside expert practitioners, master teachers, the ones who have those really strong craft skills and a desire to pass that on to the next generation of teachers. So it's very much a learning on the job through working on perhaps initially small projects, working with a small group of pupils or taking just part of a lesson, and then gradually building up over the course of the training year to a point at which the trainee can take on the role of the teacher, can plan and teach and assess pupils' progress within a number of lessons during the week with a real range of groups there. So very much one of them learning from the expert practitioners in school. But the apprenticeship model includes an element of day release. So on a Wednesday, all of our trainees are at the university or sometimes in our local professional studies hub schools, reflecting on their practice, sharing the stories of what they've done in school with one another, getting advice from me, getting advice from their colleagues. I'm deeply influenced by Wenger's model of situated learning here, which applies across a whole range of vocational training. I think Roehampton is particularly good at the bottom left of this diagram. Through their work in school, trainees learning through practice, learning through doing the craft of a teacher, trying ideas out, working with their class, actually imparting knowledge and skills to the young people in their care. And then on our Wednesdays at Roehampton, there is a reflection on that and making sense of those experiences, learning as meaning making through taking that experience they've had and seeing that in a broader context, linking that with the research that's been done into computing education, and as I say, sharing that experience with other trainees. I want to emphasise, though, the top right of this diagram as well, the becoming part of the community of computing teachers. And so we have very good connections to computing at school, the Subject Association for Computing Teachers at a local and indeed national level. And so I really encourage our trainees to get involved with that wider professional network and to take on that sense of identity as a teacher, that it's no longer something that they're just being taught or trained to do, that they are in the process of becoming a school teacher themselves. The government have a framework in place for what all initial teacher training needs to address. This is called the Initial Teacher Training Core Content Framework, and that divides the areas of professional learning into these 5 broad categories of managing behaviour, of pedagogy, the craft of teaching, of curriculum, of the subject that is being taught, of how that learning is assessed, and then a broader scope of professional behaviours. Within the core content framework, the content is separated into learn that statements, declarative knowledge, perhaps things that a new teacher should know, but also things that a new teacher should know how to do, the more procedural knowledge. And those craft skills, that understanding of how to teach, is something which is very much conveyed through that experience on placement. The other bit of the core content framework, which is really good and often overlooked, is a really very good bibliography there of things which teachers should read and be aware of the research that's happened, and indeed to critique some of that. It's worth saying that this is a generic document. It applies across all subjects, it applies across all phases, and so part of our role is to see how this links specifically to the unique challenges and indeed opportunities of computing education. Summative assessment in terms of whether a trainee is awarded qualified teacher status at the end of the course is on the basis of the existing teacher's standards. But this is now seen very much as an end point of assessment. Can a new teacher do the 8 things that are listed here, as well as be a fitting person to enter the profession? Whereas the ITT core content framework describes how they arrive at that endpoint, or at least a minimum entitlement to their training across all subjects, across all phases. From a Roehampton point of view, there are 5 things that a new teacher needs to do in order to succeed on the course. And the first and most important of that is to pass their school experience, to be able to demonstrate that they can achieve those teacher standards at a level suitable for a new entrant to the profession, that they can do all of these 8 things, as well as, of course, as the required professional standards for a new teacher. So school experience is the most important thing. And again, that apprenticeship model of teacher training places that right at the heart of what we do. We also, though, have 3 academic modules that sit alongside the school experience one. We have a couple of those around computing. So in the first term, we'll talk about the nature of the subject, effective approaches to teaching computing, how that might be assessed, and look at the subject and how it is taught in school. In the second term, we tend to take a more specialised approach, looking at particular aspects of the computing curriculum, I should say second and third term. So we'll have lectures on artificial intelligence, we'll have lectures on online safety and how to promote that. We'll do some work on physical computing. So we cover the general nature and purpose of the subject, how it can be taught in the first term, and then look at particular aspects of that in the second and third term. There's also, running alongside our core computing modules, a year-long professional studies module where our trainees are grouped with other students taking other subjects, typically in local hub groups, and look at things which apply across the whole breadth of secondary education. So behaviour management, yes, there's a particular focus on that in terms of what we do in computing education, but behaviour management skills we see as something which applies and is really important in the context of all subjects. Overarching all of those things is an expectation in terms of professionalism, that trainees are coming to school day in, day out, are behaving as an appropriate professional colleague within the culture of the school, maintaining the school's standards, but that they're also attending our lectures at Roehampton, keeping up with the work that we're setting them, and are engaging in the course in an appropriate professional manner. So a much higher expectation than perhaps many of them had when they were undergraduate students studying computer science or whatever. To help with this process, we've put together a set of reflective questions, which we would very much encourage our mentors based in school to use as a structure for the conversations which they have, of encouraging trainees to learn from their own experience, to reflect on what they've done, and to question how effective that was and how that might be improved. This is the one which is linked to that, the set that is linked to that area of professional learning of pedagogy, and we have similar sets of questions for those other areas of professional learning. In terms of our approach to teaching, I think we've come now to a view that there are effective ways to do this. This is no longer teaching as an art, that it is up to each individual teacher to find their own way in the context of their own unique school and the pupils that they happen to be with. We seem to think now There's a consensus around effective teaching looks like this. And at that general level, we have Rosenshine's principles of effective instruction as one way of thinking about this. So beginning a lesson with a short review of previous learning, we'd expect most lessons our trainees to start with linking what's about to happen in this lesson with what they've done in the past, to use questions on a regular basis, yes, to check for pupils' understanding, but also as a way of guiding their learning. Don't worry, I'm not going to go through all 17 of those points. We're also very influenced by the work of the National Centre for Computing Education and their particular approach to the pedagogy of computing, with the 12 pedagogic principles that underpin their work. And again, an emphasis on reading code coming before writing code, of making their pupils' understanding of the big ideas of computer science really concrete, often through practical experience away from the computer. Again, I'm not going to go into detail of this now. When it comes to computing education, we think subject knowledge is of crucial importance. Again, this applies to all subjects, but we know that teachers who have really strong knowledge, background knowledge in the subjects that they're teaching, tend to be the most effective classroom practitioners. So throughout the training, I'm really encouraging our trainees to get their subject knowledge absolutely up to date and as strong as it possibly can be. Our trainees often come to us with quite a diverse background in computing. Some, yes, with traditional academic degrees in computer science, who are very, very strong at the programming side of things, but might perhaps have missed out on some of the work in digital media, which is still part of the national curriculum. Other trainees, perhaps from a more diverse background, often lack that knowledge in programming at a level suitable for teaching at GCSE or at A level. So we really prioritise their developing their skills in algorithms, in programming, so that they should be able to go in there and confidently teach pupils in a GCSE class how to code in Python, for example. And the Royal Society acknowledged that this is particularly important in computer science, that a strong level of subject knowledge is absolutely essential. We can select for this at admissions, but it's really important that trainees develop that subject knowledge across the whole of the curriculum. I'd like to turn briefly now to some of the ways in which computing is perhaps different from other subjects in the curriculum, and this does of course influence the training that we provide at Roehampton. Firstly, back in 2011, our friends at Ofsted were very concerned about the quality of secondary ICT teaching as was. That the schools that they inspected, they saw that as no better than requiring improvement in almost half of the schools. So what do we have there? Position was less positive for ICT in secondary. Just under half of the schools in the survey judged good or outstanding, which is a pretty sorry state of affairs. I think this may well have improved subsequently with a much more tightly defined subject and the excellent work of the National Centre for Computing Education. But there is perhaps still a sense in which computing is not being taught as well as some of the subjects on the school curriculum that have had a place for much longer. We're still finding our way with computing education. Another aspect that sets our subject apart is the rapid pace of technological change. So yes, whilst the national curriculum and exam specifications look at the fundamental principles of computing, the devices and the platforms that we use in order to teach this change very, very rapidly, and thus trainees and indeed teachers have a responsibility to stay up to date with this. I think another aspect is the frequency, the regularity with which things go wrong in computing, that debugging has been part of our subject right from its foundation. Grace Hopper's notebook here actually sticking in allegedly the first bug that was actually found in a computer, physical bug in this case. So we're used to things not working well, and you will have all had the experience of your pupils not having programs that do not work, and how we encourage them to have a positive attitude to those mistakes, to learn from those mistakes, I think very much prefigures Dweck's work on growth mindsets. And indeed Papert, my great hero in computing education, writing back in 1980, about this idea of transferring this attitude to fixing things when they go wrong across to all of the other subjects that pupils are studying. It happens so much in computing lessons. Wouldn't it be lovely if pupils had that positive attitude to learning from mistakes, learning from failure in other areas too? I think related to this is the way in which we get feedback, particularly on our code. It's not just on programming, where there's an automatic feedback on the things that we're doing. And so pupils become very used, right from an early part, of knowing whether something has worked or not before you as a teacher can go around and mark their work or give them feedback on it. So there's an automated nature to the feedback. The code on screen there has a large number of bugs in it. It's left as an exercise to see how many of those you can spot without running the code. And then the final aspect I'd like to mention is this challenge we have in addressing the gender balance of the subject, that up until the end of Key Stage 3, computing is actually a very well balanced subject because it's a compulsory part of the national curriculum. We have good mix of both girls and boys in computing lessons up until the end of Key Stage 3. But where pupils get a choice as to which subjects that they do, it seems that by and large the girls are choosing to give up the subject at that point. The picture has got better, but here we have, in this summer's exams, only 22% of those taking it were girls, and at A level it's actually much, much worse there. The final thing, sorry, I said that was the final thing, is the centrality of programming to the nature of computing. I think Simon Peyton-Jones, as chair of the NCCE and indeed chair of CAS, puts it so very well here, that coding is not merely the message of the computing curriculum, it's also the medium of that curriculum. That one of the most useful skills with which pupils will be able to leave school is being able to write a program to get something done, being able to take charge of the technology. And this was very much part of the vision for the computing curriculum and the change which we've seen in that move from ICT to computing. And this lies at the heart of the Roehampton training. Week in, week out, I'm setting trainees regular coding challenges to help them develop that subject knowledge and to see how coding can be linked to all of the other areas of computing that are taught in school. Okay, so let's turn now, before we stop, to the nature of the taught course at Roehampton. I have 20 sessions with my trainees split across the three terms there. So we begin with a very gentle induction to the course, very similar to what I'm recording for you now. We talk about how to plan an effective lesson. We also link that with what we know about multimedia learning theory, things like dual coding, things about cognitive load and that science of learning. We talk about behaviour management because that's often a real challenge for many of our trainees initially. We emphasise the importance of following the school's routines and procedures for managing behaviour effectively, but also give trainees a set of strategies that they can use to react to events as they happen. I typically link that with engagement, which helps us think about how to get all of our pupils engaged in learning computing. We also link that with issues of race and culturally relevant pedagogy and culturally appropriate curriculums, because there's a professional studies lecture which happens at that time. I brief students on assignment 1, more of which in a moment, and discuss academic reading and writing. We then focus on the nature of computing as a subject, as an academic discipline, and look at how that's expressed through school computing curricula. We have a whole day's lectures on inclusion, where we look at English as an additional language and the opportunities and challenges that presents for those learning computing, and also special educational needs with a particular focus on autism there. Lecture 7 focuses on the particular pedagogy of teaching programming, which links and draws on a lot of the excellent work from the National Centre for Computing Education. And then we close the term with a session on how to assess pupils' learning, particularly looking at automated ways of checking for understanding through multiple choice questions and indeed unit tests for programming. The final lecture of the term is only half a day, where we look at the process of getting a job as a computing teacher, and we have our careers fair that lunchtime. After the winter break, we come back and students are briefed on assignment 2 and the importance of questioning within lessons, computing lessons included. We look at what used to be called differentiation, but now we're describing as adaptive teaching and some of the dimensions of that. And that also links back to earlier work we've done on engagement. I have a lecture on working with data. This equips our students with some of the data management skills and looks at how we can work with big data sets using programming tools, but it also encourages them to look in detail at some of the assessment data that they'll gather as part of assignment 2. We have a focus on education technology. We then look at some of the A-level topics, particularly the programming ones. Again, object-oriented programming, which comes across all boards. And AQA have a unit on functional programming, which we also addressed during that lecture. I discuss online safety and its particular links to privacy and security. That links to and builds on earlier work which students have done right at the start of the course in terms of safeguarding. So we're not leaving online safety right until the end of the course. This is just building on earlier work which all of our students have done. And again, we have these particular topics, so we'll look at artificial intelligence and machine learning in lecture 16. We look at some of the general challenges around diversity in computing education in lecture 17 there, which looks particularly at how strategies that teachers can use to have girls more engaged in the subjects and some of the challenges which socioeconomic status poses for computing as a subject. We then look at cross-curricular computing with an emphasis on creative computing across the curriculum, as well as half a day on physical computing using the BBC microbit. Lecture 19 prepares them for what comes next, and we look at the early career framework for new teachers, their 2 years as an early career teacher, and then also think a little more about their professional development over their subsequent career once they've got the ECT 2 years out of the way. We end with a review of the course, as I'm sure you would expect. There are a couple of assignments for this. So the autumn term assignments, 3,500 words of academic prose, where they reflect on the importance of computing in the curriculum. And we have a very tight focus for that on why pupils should all be taught how to program, the importance of programming for everybody, not just for those who are going to go and get jobs out in the software industry, and how programming can be taught in such a way that all can succeed. So again, clear focus on programming, but also a real emphasis, as you would expect from Roehampton, on inclusion there, on making sure that all can succeed. This is not just for some, this is for all. The spring term, it's a more practically focused assessment, which is linked to what they're doing in school. So we expect them to plan half a term's unit of work for one of the classes they teach, with a really tight integration of assessment into that unit, so that they can investigate whether that particular approach to assessment promoted pupils' learning. And I'd expect trainees to have some data, obviously anonymised data, with which to work to present the outcomes of whether that particular approach did seem to be effective or not. So that's pretty much the course as we teach it at Roehampton. I hope you've got some questions. I hope you'd like to know more about this. My email address, Twitter handle and phone number is up on the screen there. But thank you very much for supporting the work that we do. If you're interested in the work that we do, and please do get in touch.